So this is pretty straightforward. It's mostly terminology. We locate mins and maxes. I'm going to say that this point is -1, -2, and that this one is 1, 2. There you go. You're increasing in between them. You give the x values. So x is going from -1 to 1 when you're increasing on this problem. It will probably be on the trimester exam, so you might want to make sure that you're writing the proper notation. So let's just scratch that out and write set of all x such that -1 less than x less than 1. Remember that you normally put x such that and then immediately like x less than 3 or something, but if for between notation, you pin the x value in between two numbers. Decreasing. Let's use proper notation. X less than -1 to the left of -1. We'll say x such that, and then x less than -1, or x greater than 1. Okay, local max. Value is output, so it's 2. And that is at, so where it occurs, at x equals 1. And the local min, what is a maximum? What is a min? Well, a maximum is like a little mountaintop, and a minimum is like a little valley. The bottom of the valley is at a height of -2, when x is -1. Okay, what is an absolute max and min? If the curve, look at the next picture, there's absolute minimums. If the curve keeps going up forever, there's no absolute max. If the curve keeps going down forever, there's no absolute min. So we'll just say no absolute max or min on this graph. Look at the next graph. We've got some absolute mins because the graph never gets below those. We'll call them local mins also. And notice they're not exactly at plus and minus 2. Looks like it's more like -2.2-ish. And what's the height? -8. And then maybe +2.2 with a height of -8. That'll be local and absolute mins. Let's see. What is this one? Over 0, up. More than 4, maybe 4.5. Because remember, its hash marks are going from 4 to 6, not 4 to 5. So increasing, let me just highlight the increasing bit. It's increasing from here to here, and then from there on forever. Let's see, x values only. So let's set up the proper notation. Okay, so between -2.2 and 0 for x values. And then also from 2.2 on. Okay, decreasing the rest of the time. So to the left of -2.2. And then in between 0 and +2.2. Okay, local max. Again, the maximum value is the height, so 4.5, and it occurs at x equals 0. There is only one local min value. It is -8, but it occurs twice. I'm just gonna say plus or minus 2.2. Okay, so there is no absolute max because it goes up forever. But by George, there's an absolute min. And again, the absolute min is the single lowest value. It's the value. It can occur more than once. There you go. Basic idea of this stuff.